Energy. Energy. What is energy? Sometimes you feel energetic. Something has a lot of energy. You can use energy. What is energy? For our purposes, energy is the ability to cause change. There are many different forms of energy. We're going to be talking a lot about kinetic energy and potential energy and all the different kinds of potential energy there is. But there's also chemical energy. We'll talk a little bit about that too. The first thing I want to talk about is kinetic energy. If you're wondering what kinetic energy is, focus on the word kinetic. Maybe you've heard that before. Kinetic means motion. So kinetic energy is really the energy of motion. So when we calculate kinetic energy, which I'll abbreviate here as KE, if we have a formula for kinetic energy, you would think that it has some variable associated with an object's motion. Velocity. In fact, kinetic energy is 1/2 mv squared. So kinetic energy has to do with how massive something is, and it has to do with how fast it's going. I like to use football analogies a lot. Who has more momentum, the big linebacker moving slow or the agile receiver who's running fast? Well, it really depends on what their masses are and what their speeds are. Similarly, we can talk about kinetic energy. If you get hit by somebody, that's what really hurts is the amount of energy that's transferred when they hit you. So you can do a calculation on whether you want to get hit by a big guy moving slowly or a little guy moving fast. And it's actually the little guy moving fast that can do more damage, that can hurt you more, transfer more energy to you, because velocity goes as the square. So it doesn't take much more of an increase in velocity to deliver more punch. Also, maybe you're not into sports, maybe you're into guns. Bullets that have a higher muzzle velocity are going to do way much more damage than bullets that are moving more slowly. So that's why muzzle velocity is an important aspect when you're talking about guns and ammunition and things like that. Let's talk about those linebackers and running backs. Say we are given that. Let's talk about a linebacker who's maybe a little heftier than me. Maybe he's like 85 kilograms. And that when he's tackling somebody, maybe he's moving at a pretty good speed of, I don't know, let's say 12 meters per second. Well, this is all we need to know in order to be able to calculate the kinetic energy of the linebacker. Can you do that? Can you use this equation and substitute and solve? So the answer I get, 6,120. Well, 6,120 what? The units for energy is joules. Joules, joules, joules.